Okay, so welcome. And in this video, we're going to introduce and derive Simpson's rule. And so before we do that, let's just explain. So in the midpoint rule, we've been using rectangles. So we've been basically looking at the height of the function or estimating the length of the curve, the arc length, by using a constant function, if you will. With the trapezoidal rule, we were using trapezoids, right, to kind of estimate the length of the line segment, to try to figure out what the area is going to be underneath there. So we were trying to, what is a constant function, right? The midpoint formula, we're just trying to find the area under the rectangle. Then the trapezoid rules, we're trying to fit trapezoids under there to try to get that closer to the curve. Now what we're going to do is, what if we used quadratic functions, right? Why don't we try to estimate using a quadratic? So parabolas, right? So now the thing is with parabolas, we're going to need 3 points, right? So it's going to have to pass through 3 points instead of going through 2, right? So instead of one interval from, let's for example, x sub 0 to x1, now we're going to go from x sub 0 to x sub 1 to x sub 2. So we're going to actually use 3 points, right? So we're going to combine 2 of the intervals. So we're still going to subdivide in n subintervals, but we're actually going to be using Simpson's rule. We're going to actually cross 2 of those intervals, as you'll see. Okay, so if you look at here, we're going to try to find a parabola that goes through these 3 points. So from x1, x0, x1, and x2. But they need to go through those 3 points. So what we're doing is we're using a function, so a polynomial, if you will, to estimate the curve, right? To try to fit as close to this curve as you can. Okay? So we're going to use quadratics, and we're going to use 3 points. Okay? And so we're going to use these 3 points. And then the next time we're going to use these 3 points to do the next one, right? So we're going to have these overlapping parabolas, right? So we'll have a parabola that goes through these 3 points, then we'll have another parabola that goes through these 3 points, and then these 3 points, and so on. So we're always going through a pair, right? So we're always adding on a pair, right? So to go from here to here, we're adding on a pair of intervals. Okay, so how does this work? Well, we take the general expression and let p of x equal ax squared plus bx plus c, where a, b, and c are just constant coefficients. We're just going to take a polynomial and we're going to fit them through these 3 points. So that means, so the takeaway is that f of x0, which is going to equal p of x0, equals ax0 squared plus bx0 plus c, and then f of x1 equals p of x1, which is going to equal a of x1 squared plus b of x1 plus c, and then f of x2 equals p of x2, which is then going to equal a of x2 squared plus bx sub 2 plus c, right? So that has to be true, right? Because they're going to go through those 3 points, where that's what we're forcing it to do. Okay? And then also, we're going from x0 to x2, right? So that length, again, each one of these each one of these intervals is delta x. So that means going from x0 to x2 would be 2 times delta x. Okay, so that's another thing we're going to understand. So, excuse me, so x2 minus x0 equals 2 times delta x, right? Which is equivalent to telling us that delta x is equal to this distance divided by 2. Okay. What else? So we're going to use this as well. And since this is true, because again we have this delta x1, right? x1 is right between these, right? Since these are equal, right? This distance here is also delta x. So we know that x1 is right in between the two. So it's the midpoint. So we can also say that x1 is equal to the average of these two, or the midpoint formula. So it's going to be x1 plus, oops, not x1, x0 plus x2 divided by 2. Okay, and the reason why this works is because what we're doing is we're saying the distance from here is, if this is 0, this distance here is basically the midpoint. Okay, and so we're going to define x1 as the distance, the average of these two points. So whatever this value is plus this value divided by 2 will give us the midpoint, or x1 in this case. This is going to be important later because we're going to need this to substitute to simplify things out. So, so that's why I'm bringing it up now. Okay, so now what are we going to do? Well, we're going to integrate, right? That's the whole purpose of this. We're integrating from x0 to x2. So we want to integrate from x0 to x2 of f of x. We're trying to find the area. And what we're going to do is we're going to use the polynomial p of x to estimate this. So this is going to be estimated using the integral from x0 to x of 2 of p of x, oops, dx. Okay? Which is going to be from x0 to x of 2 of ax squared plus bx plus c dx. And of course, if we integrate this, we get what? We get 1/3, so a over 3, excuse me, x to the third plus b over 2 x squared plus c x evaluated from x0 to x of 2. Okay, so now, what are we going to do with that? Well, let's see what happens. Okay, so now let's evaluate this. So that's going to be a over 3 let's see here. Let's factor out a 1/6. Well, let's Yeah, let's just, we could do it now. Yeah, let's just wait. So we've got, this will equal a over 3 x0 cubed plus b over 2 x0 squared plus c x0 minus what? A over 3 x2 cubed. So basically everything evaluated x sub 2. And so if we subtract everything, what do we get? We get a over 3 x0 cubed minus x2 cubed plus b over 2 times x0 squared over, oh, hold on a second. Oh, I'm doing this, this should be 2. I'm doing this backwards. Sorry. 0, 0, 0. So this should be 2 minus 0, 2 minus 0. Okay. And then plus c x2 minus x0. Okay, there we go. Now, here I've got a difference of 2 cubes. Here I've got a difference of 2 squares. So let's use those properties and factor them out. So this is going to be a cubed times x2 minus x0 times x2 squared plus x2 times x0 plus x0 squared. Right? Okay, so let me erase this. We don't need this over here. We're going to need room. Okay, so that's this. And now we're going to have plus b squared over x2 minus x0 times x2 plus x0 plus c times x2 minus x0. Okay, so now look, now we can factor out an x2 minus x0, and I'm going to factor out a 1/6 at this point. Why? Because to get rid of the fractions, okay? Plus I need the 1/6 as your c. Okay, so I'm going to factor out the x squared minus x0 over 6, and that leaves me with a 2a, right, times x2 squared plus x2 x0 plus x0 squared plus 3b times x2 plus x0 plus 4, or no, 6. 6c, and that's it. So, okay. So now this x2 minus x0 is just 2 times delta x, right? Remember, we defined this is 2 times delta x. So this is going to be 2 times delta x, right? Which means the 2 is going to cancel with the 6, and so we get what? Delta x over 3. Okay, now I'm going to distribute the 2a. So this will be 2a x2 squared plus 2a x2 x0 plus 2a squared plus 3b x2 plus 3b x0 plus 6c. Okay, so now here's where I'm going to rearrange some things. Okay? And so the reason why I'm going to rearrange some things is because if I can get polynomials with x0s together and x1 together or x2 together, I can replace those with the function, right? Okay, so let's rewrite this as, okay, delta x over 3 times, now, I've got 2ax squared, or 2ax2 squared, and what else? I've got, I've got a 3b here, and I got c6 here. So I could take one of these, and I could take one of these, and I could take one of those together. So I get a times x2 squared plus b times x2 plus c. I've got that one. Well, what is that? Well, that is just f of x2, right? Now, or you know what, actually, you know what? I'm going to take two of those. I've got two of these. I could take two of these, and I could take two of those. Yeah, let's do that. So 2 times 2ax2 squared plus 2b x2 plus 2c. So I can factor out the 2, and I get 2 times f of x2. Right? Can I do that? Okay, let me just make sure I've got everything here. No, I don't want to do that. Let's start with what I had before. Let's see how this works out here. So I've got ax2 squared plus bx2 plus c. So that's going to give me f of x2, right? let me put it down here. So f of x2, and then what else do we have? We have x0 squared, and we have x0, and we could take another c. So let's plus, so we got ax0 squared plus bx0 plus c, and that's going to give us f of x0, right? Okay, so now, and then we got the rest of it. Let's see what's left over. So we got one of these, so we've got plus, we got one of these, two of these, one of these, we got two of those, and then we got four of these left over. So we got a x squared plus 2a x2 x0 plus 2, plus no, one of these. We got one of these plus a x0 squared. And then we got two of these, and four of those. So plus, so we've got, two of those, so 2 times bx squared plus 2 times bx0, not b2. So we got plus 2bx2 plus 2bx0 plus 4c. Okay, so that's what we got left over. Okay, so now let's go back up here. Okay, so now let's rewrite this. So we've got, this is equal to delta x over 3 times f of x2 plus f of x0, right? And then plus ax2 squared plus 2 times x2 x0 plus ax0 squared, right? So we group those together. And then we got plus 2b x2 plus 2b x0 plus 4c. Okay, so let's stop there, and when I come back, we'll finish this up and we're gonna do some more substitutions and we'll see what it looks like. See you then.